The resistance of a conductor depends on many factors such as the material from which it is made, its length, and the area of its cross-section. Let's check this.
Okay, as I said earlier in the Ohm's law that voltage is directly proportional to current. So that means if you increase the voltage, the current will also increase, and the resistance will be a constant. Okay, but if you look into the resistance only, then resistance also depends on some other factors. So these factors are the area or the length of the conductor, so area of the cross section of the wire, as well as the temperature. Okay.
With an experiment using a wire as a conductor. Here's a basic circuit with a battery, a key, an ammeter, and a resistor, that is a wire. You can change the material, the length, and the diameter, that is the area of the cross-section of the wire, and see how its resistance changes. The resistance of a conductor also depends on the ambient temperature. In this experiment, the temperature of the lab remains constant at 20 degrees Celsius.
Okay, so the factor like temperature also affects the resistance. Okay, so that's why it is important that for any lab where the experiment is performed, the resistance, the temperature of that room has to be kept constant. Okay, so that it should not vary, so that it does not affect this one resistance. Okay, so let's proceed with the experiment.
First, let's see how the resistance of a wire changes with its length. For this experiment, the diameter of the wire will remain constant at 0.2 millimeters.
Okay, so the first experiment, the diameter or the cross-section area of a wire is kept constant. It is to see how resistance varies with the length and not with the cross-section area, because we are not changing the cross-section area. So that's simple. Okay.
First, select the material of the wire.
Okay, so there are two options. Either we can choose nichrome or we can choose copper. So nichrome has high resistance and copper has low resistance. And which one do you want to choose? Nichrome. Okay, so we will start with nichrome.
Now, select the length of the wire and click Start Experiment to close the key and note down the ammeter reading.
Okay, so first the length of the resistance or a nichrome wire is how much? 100 ohms. So let's start the experiment.
Repeat the experiment using different lengths of the wire.
Okay, so let's increase the length. not varied. The thing that is varied is the length of the resistance or length of the nitro wire. Okay, so you can see, if you focus here, then you can see every time you increase the length of a conductor or a length of nitro wire, then you can see the value of current is decreasing. Yes or no? So, and we know resistance is voltage divided by current. So if the voltage is kept constant, if the current is constantly decreasing, that means what will be the value of resistance? Will it increase or decrease? Increase. Okay, so every time when you increase the length of a wire, that means the resistance in turn will keep on increasing and increasing and increasing. So let's calculate the resistance and see the value. Okay.
Plot the graph of the resistance versus length.
Okay. You can see the value of resistance here. When the length of the wire was 100 meter, then the value of resistance is almost 3184.71 ohm. Okay, but when you change the length of the wire to almost 300 meter, then the value of resistance went up to 9554.14 ohm. So that means you can see the variation in resistance is like very much. So when you increase the length of any conductor, it is affecting the resistance also. It is also increasing. Okay, let's see. Let's plot a graph and see. So you can see in the x-axis. Again, x-axis is an independent variable, and y-axis is a dependent variable. That is your resistance. Independent variable because we are changing the length of like 100 meter, 150, 100, 200, 250. Okay, and resistance is a consequence of changing the length of a wire. Okay, then again you find that you are finding one relationship, that is that the graph is a linear graph which is starting from 0. Okay, that means what does it mean? That the resistance and the length of the wire is directly proportional. So they are directly proportional. So that means when you increase the length of the wire, it will also increase the resistance of the circuit. Okay, so whenever you increase the length of the wire, it will increase the resistance of a circuit. Okay.
Now let's see how the resistance of a wire changes with its diameter. That is, the area of its cross section. For this,
okay, so first of all, when we started our cross experiment, then I said that the cross section area was kept constant as I guess 2 millimeter, yes, or 0.2 millimeter. Okay, so now in this experiment, the length of the wire will be kept as constant, but the diameter or the cross section area will be increased. Okay, and let us see how the resistance value in the cross section area.
Experiment. The length of the wire will remain constant at 100 meters. First, select the material of the wire.
It will be more easier if
Now,
we will
select the length of the wire and click Start Experiment to close the key and note down the ammeter reading. Repeat the experiment using different lengths of the wire. Using these observations, calculate the resistance of the wires from Ohm's law. As you can see, the resistance is inversely proportional to the diameter or the area of cross-section. So let's plot the graph of resistance versus 1 upon A. To do this, calculate 1 upon A for the wires. Now, plot the graph.
Okay, so you can see that whenever you are increasing the diameter of the wire, so with that the current is also increasing. Yes sir, so that means it is inversely proportional. So inversely proportional. So why? Because the resistance, when the diameter is small, the resistance is very large, and when the diameter is very large, then the resistance is very small. So that means the resistance and your diameter or a cross section of the area is inversely proportional. That means if you increase the one, the other one will decrease. Okay, so let's plot a graph. Okay, so this again is a straight line that is passing from the origin. Yes or no? But the thing is that we have in x-axis, instead of taking cross-section area, we have taken the reciprocal of cross-section area in order to show that the resistance is proportional to the reciprocal of cross-section area, but it is inversely proportional to the resistance is inversely proportional to the cross-section area, but it is directly proportional to the reciprocal of cross-section area. That means if you increase the cross-section area of a wire, the resistance will decrease because there will be the more space for electron to flow inside the wire. Okay, so that is how the resistance changes with your length and area. So in other words, if I have to write, okay, so if I have to write, then I can write that resistance is directly proportional to the length of the wire. Yes, so this can be your equation number 1. Other thing you can write is resistance is inversely proportional to the cross section area of the wire. You can use it as equation number 2. If I combine equation number 1 and 2 together, I can write that resistance is directly proportional to length and inversely proportional to answer. Okay, so this one I have to erase. So okay, so inversely proportional to the cross section area. So that means if you increase the area, the resistance will decrease. If you decrease the area, the resistance will increase, and that is linearly proportional to the length. So that means if you increase the length, the resistance will increase, and if you decrease the length, the resistance will decrease. Again, the one thing is there, whenever you remove this proportionality sign, what you have to use? Constant. So that means the resistance will be equal to rho times L by A, and this rho is known as your resistivity. So resistivity is something that we will discuss in our next class.